I ain't doing anything.
Alright, I think a good thing for this time is the m equals 0 case of that functional equation. Did you guys do it at all?
I couldn't solve the m equals 0 case. I didn't try the m equals 0. I just went for the original.
So what was the m equals 0 case? It's like this, right?
Yep.
This is the m equals 0 case.
Oh, okay.
This one, right?
Yeah. Oh, you solved the m equals 0 case, right?
Yeah.
Yeah, I solved.
Well, maybe I can't remember now because it's all here somewhere. But I mean, there's some stuff that I didn't really use, but I thought was kind of. There's lots of stuff that can happen in the m equals 0 case. So, for example, I could prove, I think that f of x is always greater than or equal to x.
Oh. Well.
So I started with this line. Wait, let me put the equation up somewhere. So it was f of x plus y, right?
Yep.
Minus f of x equals f of y on y minus 1 times x plus y, yeah?
Yeah.
Okay, so do you see how I got the first line?
Yeah.
Yeah. So x equals y, yeah?
Yeah.
Okay.
And see where it's like.
And then, how do I get the next line? Oh, okay. If x is bigger than f of x, yeah.
Yeah.
So if some point that's not true, yeah.
Yeah.
Then
you can just bound it like the left hand side, right?
Yeah.
No, so if you make x equals y, on the right hand side, all you get is f of x. Yeah. Oh, are you gonna move the thing or not? Okay, wait, you move. Oh wait, we already had the thing. Oh, it says it right there.
Okay, so we got this one, yeah?
Yeah.
Okay, next step.
If f of x is less than x, then that means what? Then that means f of x plus f of x, yeah, is also less than. Yeah.
How did I get this line?
Oh, I don't know. How did the train of thought lost?
Let's see. If x is so, one thing that's possible when x is greater than f of x, right? Is you can sub in stuff like x minus f of x.
Yeah.
Yeah. So what if you subbed in x minus f of x? X minus f of x, you get yeah, I think so. If you do x minus f of x, right?
Yeah.
This goes to 0, yeah?
Yeah.
And then you get f of x minus f of x.
Oh, okay.
On x minus f of x. Yep. Times x, yeah? And then it's minus x plus x minus f of x. So this is f of x. Yeah?
Yeah.
Is that what I'm trying to say? That's what that is, yeah?
Yeah.
Okay, then we got this, yeah? Okay, and then suppose x is greater than f of x.
Yeah.
Oh, then x plus. Oh, okay. So x plus f of x is also greater than 2f of x.
Yeah. That's true.
And that means the input here is greater than the output. Yeah.
Yeah.
So if it happens for x, it also happens for x plus f of x.
Yeah.
And so then just sub that into the top, the second one. Sub the first one into the second one. Yeah.
X plus. Okay.
Yeah. So I guess all of this kind of just
X of F.
all of this kind of just comes under like chasing. You know, like you get something for that, and then that satisfies that condition, so you put it in that. Yeah.
Yeah.
So if you sub in X, so if you replace this X here, right?
Yeah, with X plus.
With X plus F of X, yeah.
Yeah.
Then I think you get the first line.
How do you move to the second? Use the oh the F X was at the square. Ah, I see. And where did your X?
This is a good brackets here.
Yeah, that should be right. Yeah. Oh, and then you invert it and divide by. Wait, yo, huh? Wait, but then how do you get to the third line?
The third line.
The third line, how? Yeah. Because that's not under an F. X minus F.
What? How do I get to here? Do you get this one?
Yeah, we get that one. Yeah.
Okay. So I think. What?
Oh! Hey, look at the star. He uses the star as well.
Oh yeah.
What the frick? Oh, that's. Oh. What, that works? That's crazy.
Oh my god, that's crazy.
And then. Wait, what? How did that work? That's crazy. It's a weird chase.
That is.
Wait, this might just work for all of. Oh, wait, the M is. If the M isn't.
Excellent work. Oh yeah, so I guess that's what that meant, the star, right?
Yeah, you meant sub that into the. Oh, it's not challenge.
Either I used to have a good memory, or
Huh?
either I used to have a good memory, or in any case, I can't remember if I did or not. I can't remember if I had a good memory or not. Why can't I remember?
Probably means a lot.
All right. Does that work? Yeah.
Yeah, that works out.
It's a contradiction, yeah.
Yeah, you get. Unless f of x minus f of x is equal to 0. Or that certain. Oh, wait,
But it.
Yeah. Plus it goes to 0. Okay. I was just checking.
Yeah, he was just checking to make sure you were paying attention.
Yeah. So this kind of chasing, I think, actually can solve the whole this m equals 0 case.
I think, yeah.
So basically, you can kind of see like.
So, but how are we going to deal with the m? That's the only problem there.
Yeah.
That's the only annoying thing there. Maybe you have to prove like if a is greater than b, then f of a is greater than f of b first. Because then that would make it really nice.
Yeah. So here, like what this relied on was, so like if the star, what it really was, it was a way of expressing like, is its way of expressing f of some weird thing in terms of just like x's and f of x's. So that's kind of what star was, right?
Yeah.
So and the first equation is also like that. Yeah. It's just ways of expressing like sums or combinations of stuff in terms of the components. Yeah. So I think you can do this in general for m equals 0 anyway. Where is it? That's not it.
Okay, so after f of x is greater or equal to x, how do you get f of x?
Huh?
After f of x is greater or equal to x, how do you get f of x?
Oh, okay. I don't think I even used that, but that was just like a, like I used the ideas in that.
Ah. Oh wait, also like that kind of chasing mechanism
Yeah.
can be done throughout the whole wave, is that what you're saying?
Yeah.
So m equals 0 is f of x equals x.
What is going on? Why can't I
Oh
remember?
my goodness.
You wrote it.
What is going on?
What is going on?
F0 plus.
0 plus.
The positive 0.
It's in one of these chunks of working. Maybe it's here. Yeah, this is it's here. So I ended up getting this thing somehow.
What's the...
So I think I tried to do it for f of 1 and I realized I could do it for all of it.
Oh.
Oh, what the hell?
2 f of 1 squared plus f of 1
Equals
3.
Okay, so I think I used the f of x minus f of, the f of x minus f of x equals 2 f of x thing somewhere, yeah?
I see.
Oh.
X equals x moment.
Okay, I got this. So I think I chased it until x plus 3f of x. Oh dear. Okay, what about this? So f of x. So I think we have f of x plus f of x, right?
Yeah.
I think what I tried to do is I got f of x plus 2 f of x.
Yeah.
And then f of x plus 3 of f of x, yeah?
Why did you turn it on? My eyes are bad, so I can't.
Okay, so what's f of x plus 2 f of x, yeah?
Oh.
So you sub y as x plus f of x, yeah?
Yeah.
And f of x plus f of x is just 2 f of x, yeah?
Yeah.
So the f of y on y is the 2f of x plus on x plus f of x, yeah?
Yeah.
Times the x. And then you minus the x. And then it's plus x plus f of x, yeah?
Yeah.
So this gives you this. Is that right?
Yeah,
So the 2f of x comes from the minus f of x on the left.
Yeah.
Is one of them. And the x plus f of x for y is the other f of x.
Okay.
And then the x from the y cancels with the minus 1
Yeah.
x.
Yeah.
And then it's x times f of y on y, yeah?
Yep.
And f of y is just 2f of x. And y is x plus f of x, yeah?
Yeah.
Okay, so that's right. Which, it's actually a common factor of 2f of x, yeah? What did I do?
F of x, 2x. Nah, something wrong. Why is it plus f? No. Nani? Nani?
Oh no.
No, that is correct. The third line is correct.
Yeah.
Yeah, so it's common denominator, yeah?
Yeah, you take out the common denominator,
Yeah.
2 f of x and plus is 1, which is
X plus X. It's F of
Did I say I did this on Saturday or Sunday?
I'll check.
It must be Saturday, that's why I can't remember.
Oh. That's 2 days ago. That's still 2 days ago.
I can't remember it was 2 days ago.
2 days ago.
No, wait, something days ago.
That's like
2 months.
that's 48.
No,
That's
wait.
48. How
Is that right?
So it's 1 plus x on x of x over
No,
x.
I understand what you did. Is it right though? Because so if you remove the 2 from like the 2 inside the bracket, I don't know.
So factor out the 2f of x, yeah?
Yeah.
Then it's 1 plus x over x plus f of x, yeah?
It has never been good though. And so if you put 2f of x in the fraction, it's 2f of x x plus 2f of x squared, right? But then what happened to the 2x f of x over there?
Oh no, because that cancels to give you a 1, because it cancels the denominator f of x. Yeah.
Alright then.
Mm-hmm.
Thank Lord I'm not 2025. In Melbourne, Australia.
No, bro, you.
No way I'm going there. When are you? You're 12 then? Oh, 2024.
Oh, you go to bar.
You go to bar?
No, fuck. England is
I mean,
my
if you make it, first make it, then we
less reason to make now. Motivation. He hates the UK.
Oh,
I feel like I've done something with the Z now. That was Z.
Oh, but then
that doesn't make sense.
imagine Liam makes it in year 11.
How old is he?
Mid 8. 3 years. He's a 2026.
New person development. I mean, why aren't they updating the 67? I think Prequel? Most things. 107. Oh, wait. Russia conflict. That's funny.
Chiba.
You don't really like to go to Chiba, but you said.
What is Chiba?
Japan.
Chiba, Japan.
Where is Chiba? I haven't been to Chiba.
Chiba's near the, like, it's I think in the middle of Japan, but it's still.
Middle of nowhere.
It's middle of Japan, right? I think it's, yeah, it's like,
Japan.
if you
I must have got F plus
the middle, but like, on the side.
What? It's not even still.
X plus 3 f of x some other way. Otherwise, this doesn't make sense.
Chiba?
Oh, that's the city of Chiba.
You can straight away go to Tokyo.
Let me just make some notes. M equals 1.
Nabashi.
That's good.
New chapter. I'm so stupid chapter.
Oh, what? Oh, okay. So I think. Oh, what the hell am I doing? So I got x plus 3 f of x in two different ways.
Oh.
So I think. Oh, what the hell? Because remember we got the x plus 3. Remember we got x3 plus 3 f of x together, right? Remember? Remember how we had like x plus f of x plus f of x is just 2 f of x, right? Remember that?
When did we get that?
Just then. So f we got f of x plus f of x
Oh yeah.
is 2 f of x, yeah. And then last time we tried to iterate that, we got like f of, remember it was like f of, and then it was like x plus 3 f of x equals 4 f of x, x plus 7 f of x equals 8 f of x. Yeah, that's what happened here. I think it's like this thing. So f of x plus 3 f of x is 4 f of x.
F of 3 f of x is 4 f of x.
Let me just write that here. So f of x plus 3 f of x, yeah, is equal to 4 f of x.
4 f of x. 4 f of x.
Because we know that, so maybe call this a proof. We know that f of x plus f of x, yeah, is equal to 2 f of x, yeah? And then you just replace x by x plus f of x. So you get f of x plus f of x. And then f of x plus f of x is just 2 f of x, yeah? And that's equal to 2 times 2 f of x. So f of x plus 3 f of x
Is equal to 4 f of x.
equals to 4 f of x, yeah?
Okay.
Alright.
Wait, that's really nice.
Okay, so then the other way of getting 3 f of x, yeah,
Is using
is
that.
that y equals x plus 2 f of x.
Oh, we already got that.
And we already have that, yeah.
Where is that?
No.
Oh, yes.
So,
Indeed.
so you sub that in, right?
Yep.
And you get, so what was our formula for,
Yeah, keep going.
Yeah, so we have a formula here, right?
Yeah.
So it's that expression over x plus 2f of x. That's the f of y on y, yeah?
Yeah.
So it's
So 8. Wait, but then.
so it's this expression,
Yeah.
yeah, over x plus 2f of x.
Yeah, you put it down a second.
Oh yeah, sorry.
Oh wait, did you cancel stuff out? We did.
Yeah, so basically this is equal to 4f of x, right?
Yeah.
So then that'll be 3f of x, and there's 2f of x on the other side, yeah?
Yeah.
So then it just becomes f of x, yeah?
Yeah.
And then this thing here, so this is 2f of x, 2x plus f of x plus, and then and then I times it by this, right? Because that's the input, of f.
Yeah. Or you get wait, you just get quadratic kind. F of x squared plus x plus f of x is equal to 3x squared. You get the quadratic one.
Yeah, so you get a quadratic. Do you agree we get to this?
Yeah. It seems like everything agrees.
Do you agree to this?
Yeah.
And then you get to here, yeah?
Yeah.
Okay, maybe this is your exercise and you solve that.
Isn't it pretty simple? It's just f of x is equal to negative x plus minus x squared minus 4 no plus 4 no plus oh that's actually 25x squared. 25x squared on 4. So you either get x or you either get like 3 on 2x.
Yeah, okay.
Yeah.
Minus 3 on 2x.
Yeah, minus.
Because it factorizes, yeah.
It can't be minus.
Wait, which one?
So this one factorizes to this one, yeah?
Right, negative 1 plus minus 5 all on 1.
Plus or minus 5 just counts as minus 5.
All on 4.
So it factorizes that, yeah?
Yes.
Yeah, you did get negative 3 on 2. Always just 1. 1 negative 3 on 2.
Yeah, but f of x can't be negative, so
So it has to be
It has to be f of x is x.
This is such a weird proof. Okay, for the m now.
this is kind of like if you don't need to solve the problem and you just need like 1 point or 2 points to win in Kazakhstan, make the TST.
Maybe having okay. How do we apply this to all the steps? Okay. The important step was f of x plus f of x is equal to 2 f of x. How do we get that?
Sub in x equals y. Okay, so m equals 1. Do you want to try? Is that what you're trying to do?
Should be m equals 1.
Yeah, I'm trying to go for some of that. Well, where the f actually exists is the difference. I think you can't do a strategy that like specifically cancels out like the f of 1x. You have to just you have to like kind of just apply your n equals 0 to n is 1 exactly the same. Or try it and fix it around. No. Push f from fine. That's not so
Look, x equals.
oh wait. Yeah. I see.
It's like more.
It's more 8 than is equal to f of x minus x plus f of x. Oh crap. So you get 3 f of x.
I think I've done this calculation already before.
Actually, did you try n equals 1 as well?
Maybe. I remember I got f3 f of x minus x. It's somewhere on the board.
Okay. So f of x is always larger than a third of x.
Yes.
Wait, but then I was actually slightly curious. Oh wait, no, I can't get it. I was just gonna ask. I was scrolling and I just
Right, so if we applied the same principle, what would you get? F of, if you put x plus f of x instead of x, right? You'd get 3f of x minus. You get 4f of x, right?
Yeah.
Is that right?
Yes. Equals.
3f of x minus x.
9f of x minus 3x
Minus
minus
x.
minus x. So it's like 8f of x minus 4f of x?
Wait, really?
4x?
Oh. Isn't it? Oh, you times by 3, is that what you're doing? Oh, I see. 9f of x minus 3x minus x minus f of x. Yeah.
Yeah, it's 8f of x minus 4.
did you put x as f of x plus x?
No.
Yeah,
So now you got f of x is greater than 2x.
getting closer.
Oh, what if you did it again?
Do it again. Again.
Oh,
Spam the same one trick. It works.
You get
it's only didn't change that.
12f of x.
Okay. This is different to what we had before, isn't it?
Yeah, but the second one we had x plus 3f of x here. But if they're all identities, then but they're really the same. But it's just like, how do you get 4f of x another way? You need to sub y equals 3f of x,
Yeah.
which is slightly problematic because the y comes out as f of x now. Right, I'm curious what happens when you do this one more time.
It is
One more time.
Yeah.
I don't think it'll be that.
Three.
It's not pessimism, it's just us. I just
I know.
Oh, now.
I don't think it would be that useful.
24 minus 4, yeah?
Yeah, so 20.
I should just factorize this. Okay, 4 first. 6f of x minus 2x minus 2x. This is. Wait, why am I minusing 2x?
Factorization makes it more confusing for me.
Yeah. It's because you already did that step, that's why.
Yeah.
Oh.
Yo, wait, what? Oh,
Wait.
yeah, that's right.
5 minus 3. 5 thirds. Wait, is it getting closer?
The 5?
What do you mean?
F of x has to be greater than 3 on 5.
Oh! That is closer.
You could. Oh, wait.
Take
Take
the limit.
Could you take a limit? I think that works. If you can continually find sequences of fractions that keep going and approaching 1, and that's great. F of x is greater than equal to that.
Just
Then
replace f of x again with that.
So then f of x is greater than equal to 1. F of x is greater than equal to x.
Yeah.
Oh.
Oh.
Mm.
Oh yes.
Oh.
Yes. 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 Yes.
Wait, but how are we sure it keeps increasing?
Because
We just need to know what the
sum in
sequence
f of x
is.
again.
I think we can find a formula for this sequence.
Three.
Because it doesn't really matter what goes in the f on the left, right?
Yeah, it is. I think it's a recurrent.
Okay, yeah, so it's So it's what's the recurrence?
That's the recurrence.
So 3 minus 1. The number here. So it's this number. It's this number here
Yeah, and that
times by 3. Yeah.
yeah.
Minus. So if this is like A and this is, oh, this is not good. You times it by 3.
And you minus it by
And you minus 1. So if this was like A and this is B, right?
yeah.
Then you do like the fraction you would get would have,
Next one would be 3A.
it would be like 3A plus, what is it? 3A minus 3B, right?
Yeah, I think so. 3 minus 3B.
So 3A minus B.
3A. No.
3A minus B.
Oh, 3A minus B. Yeah.
Minus.
And then
Yeah.
and the X would be just A
minus B.
is it minus A or is it it's A plus. Ugh.
Isn't it A?
It's A plus B.
Oh.
Oh wait, is the B is the we're saying
I forgot this question already.
so it's minus
It's minus A minus.
oh, A plus B. Yeah.
Wait. Huh? Oh yeah, it's A plus B. Oh yeah. Okay.
Okay, so this is like this is like our
Technically, that's larger than A and B.
It converges to something. So it's unbounded. I mean, like it's bounded by 1. But you have to prove that.
I think.
So basically, like, we can get as close as we want to 1 if we iterate this enough times.
Yeah, we wanted
Yeah. So the next one will be like 3 times the denominator. So this A is the denominator, right?
Yeah, A is the
3 times 3A minus B on like 3A minus B plus A plus B. Yeah.
Oh, it actually becomes nicer. And then minus
4A.
Minus A.
Yeah, minus A plus B on the bottom.
What did you say?
Minus A plus B on the bottom.
What do you mean minus A plus B on the bottom?
You have like the 3 times.
Oh, what do you mean like this?
Yeah.
4A on 8A minus 4B. What the hell? A on 2A minus.
Wait, what? Wasn't it B on A before? It was B on A.
Doesn't think it was.
It starts off as B on A.
B on A.
Oh.
Hey, freaking flip.
It's A on 2A minus.
Yeah, A on 2A minus B basically.
So A minus B.
Yeah.
That's fun.
So you can just define your recursion like that actually. Okay, then if we define a recursion like that, we know that the denominator just goes off.
Oh,
Like,
it is.
yeah, do it like that.
It is increasing. It's strictly increasing.
And then,
So does it increase to 1?
I mean, okay, yeah, but does it increase to 1? Like, how do you know that?
Well, if it's it's strictly increasing. It's strictly increasing when A is not equal to B. So
Yeah.
since the
A is bigger than B, yeah.
yeah, and since that is only equal to that when like it will never
Yeah.
be equal to B, so it'll increase
Because as long as you get as close as you want, like if ever it's less, it's gonna screw up one of those ratios.
Yeah, it will never be larger than 1. Because like, if the previous term wasn't larger than 1, the next term can't be.
But if you can get as closest to 1 as you want,
Yeah, because
If
it's strictly increasing and it can't get larger than 1. So it has to.
but it might not converge to
Oh,
1.
Wait, then if it converges to something else, can we like assume it converges to C? Try and look at what happens when it's time.
It's like a long key.
Is it like is it bigger than
Wait, did the B literally cancel one of the A's on the bottom? It's like,
Yeah, they go crazy, yeah. Yeah, what the hell? Oh wait, what?
did it again.
You're right.
So what's the next one then?
This is a well-known mistake.
You're actually becoming more and more like
No. It's like you can change that to 1 minus b or 1 minus a minus
You talking about this one?
yeah
1.
1
So like if we do
One?
like
yeah you do 1
A
minus
plus
b minus
A minus B minus
yeah, and you prove the other fraction of efficiency.
That's quite easy.
that's equal to 1 minus A minus B on 2A minus B. Is that right? Yeah. Oh, so these A minus B's have a little bit different meanings now. So we'll keep going.
Oh, because the sum is strictly increasing.
Oh, it is? Which
The
sum?
sum of the numerator and the denominator.
Uh-huh.
So
It's unbounded. It's like,
so 2a minus b. Like that means the a is unbounded.
oh, that the A is the denominator.
Yeah.
You mean, yeah, the B is, wait. Oh, because the A is the numerator.
Yeah.
Let me just write some stuff here. A minus B. Yeah, it's weird. Like if it was instead of a difference, it was like another sum. That'd be like a continued fraction.
Oh.
But it's like the difference. It's like the top is okay. The denominator is like a difference, and they followed like a slight different rules. What would this one become?
Wait, wait.
Oh, wait. Hold on. Don't you have to take like 1 minus that? I just sub it straight into the.
Oh, I'm going from here right now. I'm going from here to the next term.
Why is it 3?
I took the sum of the numerator and denominator. I was using this formula.
Oh, doing that one. Okay. What?
You have x on y. And it goes to 2y and 1. That's actually interesting.
You get 2/3 now. Okay?
Yeah. No.
Yeah. Well, like this.
I'm just reversing it.
A minus 6. 2a minus b is 6a. Wait a sec. Wait, isn't that meant to go to like 2a? Very confused.
It seems to always stay at minus b minus p, you know? From there.
Plus 1 plus 1 for the
Then you do
plus 1 plus 1.
10a minus 2b, huh? Over, that's 18, 14a minus 2b again.
It is plus 1 plus 1.
Oh my god. Wait, that proves it reverses 1.
Yeah. Yeah.
Wait, is it literally just plus 1?
Yeah, it's
Yeah.
just plus 1. And you can just, that's like,
That approaches
by
1.
like 2 k a minus b over k plus 2 a.
It's the basketball level,
That's the basketball level?
isn't it?
What is the basketball level?
Oh, the basketball lemma is like if you have a fraction. This is the lemma I made up.
Oh.
It's like if you have a fraction, and the fraction is less than 1, right? And you add the same thing to the top and the bottom,
Oh, that versus 1.
it gets bigger.
Yeah.
That's the basketball level.
Yeah, because it's like your shooting percentage, right? If you make, it's like the bottom is the number of shots, the top is how many you make.
So
If if you
I
make
thought
one,
the
you're gonna
basketball-
increase your
I
percentage,
thought
right?
the basketball lemma was.
But
there
the
is no
tricky
limit
part
to
of the
how-
lemma is if it's greater than 1,
Oh,
then it's
it
going down.
increases.
Because 100% is worse than,
Oh.
or better than 100%.
If you're shooting 150%,
You're
you make
you're decreasing your percentage by making shots.
Damn, bro. Last year I hit 150% of my shot, but now I only hit 100%.
I have decreased.
I decreased. I made 3 out of 2. I made 3 out of 2 shots. Wait, one of the shots shot 2 balls at once.
Okay, so then
Wait, there's this game where you can actually do that. What?
so then the question is figuring out this limit, right?
Yeah.
Limit as k goes to infinity,
It goes in the basket.
and it's just like it's just like
K
1 plus k a minus b over 3 plus k minus b. Yeah.
Yeah.
Oh, okay.
Okay.
2, yeah. Okay.
That's like a song. Man.
That is so yeah. That's just
Well known.
That's just one.
Do you know how to prove it?
Okay, you add 2a and you add 2a to oh.
Oh.
Well, you add 2a and minus 2a. You get a 1. And then the other part of the fraction is split 2. Okay, the other part I'm pretty sure is
Probably.
yeah, probably.
Yeah, I guess that works.
Yeah,
Minus
2a
b.
2A.
Minus
Oh, minus 2a. Wait, what the? Why is there?
No, he pulled out the negative sign over there.
There's no. Just k plus 2.
And
Okay.
K makes it further.
Yeah.
So
Yeah, I think the standard way to do this kind of stuff with this
That's not the same.
limit is just divide by k. I think that's the standard way.
Oh.
So then you get a
And then each of
minus
your-
b on k.
Oh wait, that's like school way.
Yeah, the school.
never
This
done it that way. Think about this one.
2a on
Did you do
k
it that way? Did that?
I knew
Plus
about that.
a-
I don't.
I knew about this method because that's what textbook.
Yeah, I saw it as well.
minus b on k.
Yeah, that's just a.
And then it's a on a, then it's 1.
For some reason that feels more dodgy.
This feels more dodgy.
It just feels dodgy.
It feels less like your skin's touching it. Like yeah, it feels like
Your skin is less touching it.
you know what I'm talking about. Like, it feels less like you're with the thing, like
Doing the thing.
on the battlefield. You know what I mean?
On the battlefield. In the
Oh,
trenches.
so we proved for m equals 1 that f of x is always greater than equal to x.
Yes.
And then we will proceed to not use it to derive the final solution, just like in the m equals 0 case.
Yeah, like we get a couch thing.
I think it's helpful. It proves something about the range. See, it's unbounded for.
Oh no, that means f of m of y is greater than equal to y, isn't it?
Oh.
That means f of 2 of m is greater than equal to f of m, which is greater. What? F of
No, but this is for m equals 1. I could prove the for m equals 1 doesn't work for other m.
no, I think the same. No, I think the same method will work.
Really?
Yeah, I have a feeling it will.
Now let's try m equals 2.
I don't think it'll be that extra. No, the only reason why this works is because you're looking at the f of x. Like you're looking at the right hand side, and that has to stay positive.
Minus f of x, yeah,
Yeah.
equals f of y on y minus 1 x.
I feel like at this point you can just say f of m, f of x. I mean f of m of y. I don't think you're going to.
Okay. F squared.
So let's keep going. Then we set x equals y.
It doesn't really not seem like it's.
Calm down. Oh wait, there might be a bit of a complication. I look at it.
Yeah, like once you start solving stuff into the f of f's, like the f of f's just keep on.
Yeah, shh. Oh, shut up. Shut up.
Shut up.
Shut up.
Okay.
Okay then. Now what do we do again?
Okay.
Oh,
Okay.
we moved the f of x over. And then. Wait, this seems a bit.
Oh crap! It's like 6:15.
Yeah. That's why I
Keep on going.
f of x.
We should go to 8 sometime.
Yeah.
Yeah. We're going to 7 on Wednesday.
Yeah, we could try. I don't know. We could try something after basketball. Maybe at Epping Station.
Wait, I missed
Oh,
one.
that's food.
Oh wait, what were you saying?
Oh, what?
What?
What are you saying? I don't know.
Yeah.
Wait, he's saying we should eat something.
Nah.
Oh, what? That's what you're saying?
Nah, that wasn't what I was saying.
Wait, what were we saying?
I think it was what you're saying.
What? What was I saying? What was he saying? What was he saying? I do not understand.
Okay, do some x for x now. What happens? We don't need to really look at the left hand side, only look at the right hand side.
Yeah.
Oh, that
It's because there's kind of like two unknowns.
Yeah, that f of yeah, the two does make a difference. You were correct. Yeah. Doesn't work. Shut up.
Shut up. Bro, my pants are here.
Oh,
Wait, it's puzzle.
alright. Let it
I
stop.
think we're gonna have to.
So m equals 1 remains open.
M equals y remains open.